Good morning all. I welcome you all for the next lecture series. In this series, we are going to discuss about the nodal analysis. So I think for the last class, we have discussed about mesh analysis. In that, we have to discuss what is mesh, how to find the mesh current, and how to apply KVL. And based on the KVL, we are forming the equations and solve the unknown current. So here we are going to see the nodal analysis. We will enter into the class sessions. We just recall the component, what is circuit, basic circuit, and what are the components, what is current, resistance, mesh analysis, KVL, KCL, all those things. And what is KCL and KVL, that we know that KCL is total number of current entering into the node and leaving from the node is equal, that is called as the KCL. And KVL, sum of current voltage drop around the circuit is equal to 0 is KVL. Ohm's law, that is equal to I into R. So all the informations also we are recalled in the last session itself. So just we have to recall. Mesh analysis just now we are recalled. So just we have to enter into the session. So before going to the session, what are the topic we are going to discuss today's lecture is what is node and why it is node, how to find the node, how to find the nodes, and steps to follow, solve the equations, and apply how to apply KCL and real time applications based on the node. So all the information we are going to discuss in this class. Shall we enter into the class? Yes. So what is node? A node voltage is the application of KCL. I just now we are referred, and see the diagram. Here the V1 is called as the unknown voltage of the particular that is circuit. So in this node, there are three elements are joined at the same point. So more than two elements meeting at a point, we have to consider as a node. Here there are two elements only joined, and here also there are two elements only joined. So based on this, this is also node. The other six nodes are there. 1, 2, 3, 4, 5, 6. In that, normally first you have to consider the nodes. Among the nodes, one of the node considered as a reference node. So here we are taking as a point. This point is a reference that is connected to the ground. The voltage of the reference node is 0. Right. Once again, I repeat. And how to find the node? Yes, more than three elements are meeting at a point. That point you consider as a node, or more than two elements meeting at a point. That node we have to consider as a node. Clear? In that, how many nodes are available in the circuit? Among this, one of the circuit we have, one of the node we have to consider as a ground, and voltage that is considered as the reference node. Voltage of the reference node is 0. Good. Sure. Okay. So today see the diagram. So definition of node is to find the unknown voltage of the circuit, we are applying KCL and find the voltage. And node analysis method is the application of KCL, right? And see the diagram, node analysis. That is, here there are two. How many nodes are there? Yes, VA, and here we have to say it is 0 volts. Very good. And role of the node analysis means we have to solve the complex circuit to find the unknown voltages. Good. So already I told you how to find the node voltages. That is, node voltages is equal to admittance is equal to reciprocal of impedance. What is meant by admittance? It is the reciprocal of resistance, that we called as the admittance. Sorry, admittance is reciprocal of impedance. What is meant by conductance? Conductance is the reciprocal of resistance. Once again repeat, admittance means reciprocal of impedance, and conductance is reciprocal of resistance. Here 1 by R, this is 1 by Z, right? The voltage normally the resistance value of here in the node analysis 1 by R only you have to consider. Alright, so how many nodes are there in the circuit? VB and then VC. So two nodes are there. In there are here the reference node will be selected. Right. Write the equation for node 1 is I1 is equal to 10 by 10. That is 1 amps. Normally, when we are going to solve the node method, definitely it is easy to solve. We have to consider the current source because we are applying KCL. So if the circuit consists of voltage source, just we have to change into current source. And how to convert the current source means normally the RPS, that is battery, consists of the internal resistance. So internal resistance, whatever the value here, whatever the value of the source, that is not a concern. So I is equal to formula V by R. So V is here is 10 volts and the resistance also 10. So I1 is equal to 10 by 10 is 1 amps. Here also the 20 volt supply source consists of the internal resistance 10 ohm. So V by R is 20 divided by 10, 2 amps. And make it this into the circuit, that is 1 amps is the current source. The same value of resistance is here you have to draw in parallel with this source. This is the procedure. You have to convert voltage source into current source. Just keep in your mind, if the voltage source, the resistance will be in series, but the current source, that is internal resistance, will be in parallel. The mentioning here, there are 2 amps. You have to find out the amps. The same value of 10 ohm is connected in parallel. Now you are converted voltage source into current source and rearrange the circuit. Now we have to find out the value of V1. So for the V1, there are two sources are available. So 1 plus 2, V1 by R 10 and V1 by 20 and V1 by 10. So V1 is taken out common, and 1 by 10, 1 by 20, 1 by 10, the value is 0.25. So V1 is equal to V divided by, that is I by R, that is 3 divided by 0.25, which is equal to 12 volts. So current through 20 ohm resistor is I20 is equal to V1 by 20. V1 by 20, V1 is 12 volts. So 12 divided by 20. The current through the 20 ohm resistor, that is 20 ohm resistor, is 0.6 amps. Okay, this is the procedure. We have to find out the value of node voltage. And I'll just give the problem. You have to solve it. V1 and V2. Here there are three nodes are there, V1, V2 and reference node. For the V1, we are considering 1 by 12, 1 by 2, which is equal to 5. Here the node 2, 1 by 12, 1 by 6, which is equal to 2. So solve this equation and find the voltage of V1 and V2. Then this is the empathy and the define of this problem. And application of this node analysis is power distribution system, renewable energy, and then soft tools, automotive systems, everywhere we are using the node applications. And today's summary is how to find out the node, what are the steps we are following, how to apply the KCL to find the equation, and finally find out the unknown voltages of V1, V2, and how to find out the nodes also we have discussed. These are the references you have to refer, and see you in the next session. Thank you all.